Great. And so before we actually do the R side of tidyr and sort of understanding those really important functions, it's important to understand why tidyr even exists and what the sort of goal is. And so when we keep talking about, how great tidyverse is and how there's this common, underlying grammar and philosophy, we have one unifying principle in the fact that everything uses the tibble. But you might be asking at this point, well, data frames and tibbles are very similar, and so yeah, tibbles have a couple of nicer properties. But what exactly is the sort of special grammar? And so this is actually the secret sauce here. So tidy data is what it's called. And it's really just this philosophy based around three simple rules that you're going to think are trivial, but actually are pretty heavy lifts in a lot of circumstances. So they're all related, and so I'm just going to read them off here. So the first rule is that each variable must have its own column. And we've sort of been assuming that throughout our analysis so far. But each observation must have its own row, which is also something we've been assuming. Then each value must have its own cell. And so the implication is if you have all of these, each data set is going to be in a tibble. And so that is the common grammar that is found throughout Tidyverse. And so again, it seems really simple, but it's actually sometimes pretty difficult. And so I want to visually show this just so you understand the three simple rules. So by each variable, we're going to have a column, so country, year, cases, population, etc. That's going to be our variable sort of columns here. Then the observations, so for each actual, row here, so Afghanistan again, Brazil, China, those are all given their own row. And these look like duplicates, but we'll see why in a second. But each value gets its own space. And so we see that because the year here is a variable and there's two different years for each country, there's going to be two entries for country. And then each of those is going to get its own value in a cell. And so it seems redundant, but it's actually just allows us to have a unique location for each bit of data that we're going to work with, which allows the manipulation to be so much easier. And so we're going to see why in a second. It's helpful to have these three different rules. But one, pushback you might have off the top of your head is, well, this seems obvious. How else would you store data? And it's because most data sets are not tidy. Usually we prioritize the ease of data collection and entry rather than the actual data storage to make sure it's the most useful. And so by making your data tidy and sort of following these rules, it's way easier to sort of do your analyses in the Tidyverse, but also in packages outside of the Tidyverse, because they all sort of make this assumption in some way or another. And when we communicate or do our data analysis, we think that we're doing this, but in a lot of ways we're actually not. And so in a second, we're going to move back over into RStudio, and we're going to see exactly how we have a couple of data sets that look very familiar, that look like they might make sense, but they are in fact not tidy. And so I'm going to show you a bunch of different functions that are going to allow us to have tidy data. And so this is the actual data cleaning and what most people will refer to as data wrangling. So these are the sort of core functions that you'll need. And then I'll sort of reference some more helpful ones outside, but this is sort of the very fundamental, most important functions that you'll need to succeed in data wrangling in R. Great, we'll see you over there. Great, so we're back into our Markdown file and RStudio to sort of work through four really basic but very key functions in data wrangling. And so the thing to note here is the actual usage of the functions are not very difficult. I think what's far more difficult is actually picturing how you want your data to look, and also dealing with the actual format of your data if it's not in a way or it's not sort of presented in a way that's easy for you to go ahead and sort of use these functions. And so the assumption that I'm making in this workshop is that you have data that's not tidy, so it's still very real, very messy, but it's not sort of problematic. So you sort of fixed individual values that were an issue through your data exploration or things along those lines, and those are corrected. And so you shouldn't have any crazy thing going on, but you've imported your data and it's just not tidy. So we have quite a few data sets that are sort of implemented in tidyr to let you practice this. And so we're going to engage with a couple of them here. So one of them is table 4a. And so if we print that, we see a pretty familiar looking data set. So we have a 3x3 table, and we have this variable country. We see that in the year 1999, in the year 2000, these are sort of stated or being used as column names or variables. And then we have some sort of count or cases if it's like, disease oriented or something along those lines in each country. So we have, a value for Afghanistan in 1999, a value for Afghanistan in 2000, and so forth. Now, like we mentioned, this might be very familiar and make a lot of sense to us, but it's actually not tidy. And what I mean by that is it is essentially using the year or individual values of the year as variables. And so instead of sort of using these explicitly as variables, we need to abstract out the fact that the commonality between 1999 and 2000 is that they're both years. And so really what we want is to have a sort of table where the country is the first column name, and we don't have to change anything for that. But then instead of 1999 and 2000, where there's one number in each of these columns, we want a year and a count. And so that would essentially look like Afghanistan, the year 1999, 745. And then in the second row, it's going to be Afghanistan again. So we're going to expand this out and then have the next year, 2000, and then the appropriate counts for that. And so, again, this seems weird because it looks like we're repeating Afghanistan, but really we're just following that rule where each data point has its own column or has its own cell, and then each variable has its own column, and each observation, i.e. there's two observations across each of these years, each of those has its own row. And so it actually turns out once you visualize what you need to do, so country, year, counts from this original table, the command's really easy. You can do it in 2 lines, technically even 1 line if you would like. But if we're going to use the pipe here, we're going to call up the data set that we want to alter. We're going to pipe it, and then we're going to use this function, which is pivot longer, and we're going to pivot the data in a way that fits our tidy format. So the first entry is we're going to sort of call up the actual columns that we want to pivot. So in this case, 1999 and 2000. I'm going to call them by name. And we're essentially going to say that we want to switch the name of a given column to year. And then we want to add the values in each of those to a new column called cases. And so when we go ahead and do that, we're going to have country, year, and cases. So again, this is referring to the things that we want to change or pivot. So this and this are going to be pivoted. So we're collecting these. We have the name here and the values here. And we're going to say we want the names of those, so 1999 to 2000, to go to a year column. So 99, 2000, 99, 2000, 99, 2000. And the values that were in those old columns, we're going to put in a new column called cases. And so we see that the values are correct here. Now, this is an easy command, but you might want to think about, what is a sort of unit test that I can sort of write to make sure that it's pivoting in the way that I would expect. And so I'm not going to show you one here, but one easy idea would be to look through your data and pick random points. And we would try to make sure that after we run the pivot command, the cases are still related to the year and the country. So we see here that China in 2000 had this many cases or counts. We would still be able to pick out where that would need to be or where we would expect that to be. And so we can sort of see, like check to make sure that indeed when the year is 2000 and the country is the same, does the case count match? And so there are different ways you can write that up. There are probably better unit tests you can pick, but definitely try to think about, how do I validate or convince other people that when I'm making this data transformation, that is in fact the one that I'm intending to make. Now, another example, just to make it really clear, is shown here. So if we have a different table, so table 4b, and I'll just print it so we know what the original looks like. So we'll do this, table 4b, and we're going to go ahead and run it. We see that it is still not tidy, so the original is not tidy. So we have country, 99, 2000, and then all these are actually population counts. So we have these larger numbers here. Great. And if we want to pivot them again, so we want these to get their own sort of observations. So we're going to do these two columns, 99 and 2000. We're going to take the actual names and how they relate to this country or its respective country to a new column and put the values to population. Cool. And then I know it sounds like I'm sort of beating this to death here, but it's important to sort of think through, once you know what it looks like, it's relatively easy to do, but it's very important to sort of think about, where your data are now and how you want them to be transformed. Because after that, you just select the proper function, and then it's relatively easy. This is something that's covered in the textbook that I'm not going to cover today, but I just want to show you a brief example of how to use it. Let's say table 4b and table 4a are two different data sets and we want to combine them together. If we know that country and year are the same, but the only difference is we have cases and population, we can sort of combine the two of them in a really nifty way using this function called left join. And instead of just having country, year, cases, and then a separate redundant data set where it's country, year, population, R is going to be able to combine them together. And so this is one of the ways where if you're very intentional about how you set up your data and you're running an experiment with the same subjects or you're doing a survey of the same people over a year with different responses, this is a very easy way to sort of combine them like that. Great, so I just wanted to sort of point that out to you. Now, I want to introduce you to pivot wider, which is actually the exact opposite of pivot longer. And so this is used when you have an observation that is scattered across multiple rows. And so if pivot longer, right, is when you have observations across multiple columns, so year being spread out above columns, this is when it occurs across rows. And so these are still cases in population, but our example data set now is called data or table 2. So if we go ahead and run that, we see that we have something that looks familiar. So we have country, year, type, and count. But you'll notice here that essentially cases in population are actually variables, right? So these are under this idea of type, so cases, population, etc. But we actually want it to look something closer to this. So we have, country, year, cases, and then population, because here this is sort of a redundant sort of formulation here, where really this case should be here and this should be here. But population should be its own variable, and that gets its own column for each of these entries. And so that will actually cut down the number of times we're seeing Afghanistan, Brazil, China, etc. And so it should look like this. Now, this is also something that you could do relatively easily. So you call up the data set, we have our pipe, and then we just use pivot wider with the same sort of logic. So we're going to say, well, we want to move sort of the data that's in this column called type. So this is type. So that's where it's coming from, the names are coming from. And where are the values coming from? Well, they're coming from count. And so what we're going to be able to do here is pivot these into new columns. So all we're saying is where are the names coming from, where are the values coming from, and it's going to automatically pivot them into their appropriate new columns. So really easy to actually write the code, but harder to visualize. So country, year, type, count. Type is broken up into two columns, and it says where are the respective values coming from those types. It's going to pivot them up into columns and then rows. So cases, population, and then we have this going on here. So relatively simple. You just need to know what exactly is wrong with your data and how to get it tidy conceptually, and then the function is really easy to use. Great. Now let's introduce a new problem here. So when we have two variables and they're contained in one entry within a column. And so this seems a little weird, but it's actually really common. So this is when you have the rate. And so, in Excel, for example, you might have equals observation 1 divided by observation 2. And if you leave that as plain text, it might be number / number, like so. This will make a lot of sense to us where it's the actual rate, but the problem is we can't really do anything with that, right? So we're sort of bound by the fact that this is a character. We can't sort of do more math on this. These are really two different observations put together in one row. And so what we need to do is sort of break it up. And it's really easy to do using the separate function. So all we need to do is say what the column name is in the data set. So say what the column name is that we want to do something with. And then we need to specify how do we want them broken up. Well, if we remember from our other data sets, this is just cases in population. So 745 is the case number, and then after is the population number. Great. So that's all we need to do. And I'm going to just tell you right now, you're going to want to use convert equals true. And what that's going to do is it's going to take what the actual thing is that you're breaking up, and it's going to guess what the actual data type is. So for example, 745 should be an integer, so it's probably going to guess that it's an integer, and it's going to convert it for you, so you don't have to do an extra step on top of that. If you don't have convert, it's going to assume that whatever the input is, which rate in this case is a character, it's going to assume that what you break it up into is also a character. So I like to have convert on just to make it easier in one step. And when we run that, we see that it's going to go from this, where we have country, year, rate, and now we're going to have country, year, cases, population. And so if we really want the rate, what we can do is just mutate this using the mutate function, add another column, which is just cases divided by population. And so then we have a new single number for each of these called the rate. But we don't want to sort of have two different observations combined into one and then have to, somehow manipulate that within its current form. So that's just another way to get it into a tidy format. Great. Another thing to note with the separate function is it's assumed that it's just going to break it up wherever there's a non-alphanumeric character. And so in this case, it's just the slash, but you can actually sort of specify what it is. So using this sep argument, we can explicitly say that it is the slash that we're going to break up. But if it was a period or an underscore or something along those lines, you're also able to do that. So it doesn't have to be specifically rate. It's very sort of versatile in terms of how you can use it. Great. Also, just one last plug. So if you want more information on actually what sep is doing, so it's its own function in R, you can check out the chapter on strings that I mentioned earlier. Great. And so the last function here is unite. And so it is the inverse of separate. So all of these are related again. So separate is the opposite of unite. And it follows the same trend as all the other ones. So you just need to sort of think about what is wrong with your data, and then you can sort of put it into one line. And so again, I'm going to print this before so we see why it's untidy, and then show you how to fix it. Now, one thing to note is I've never actually used the unite function before because most data sets would not be in a format like this. So the textbook also mentions that they rarely use this. And so this is just something I'm putting here so you know, and it sort of completes out the nice fact that there's 4 main functions, but this is the least used of all of them. And so this is a pretty silly example, but there might be a case where it occurs. So, this is when you have country, century, year, and rate that we had before. So there's 2 things that I would do to tidy this up. One, I would break up the rate just like we did before with separate. But then I would actually combine century and year because this is the same thing. So when we have the observations, these rates are occurring in the specific year, but it doesn't really make any sense to break the 2 of them up. And so if we want to unite them, all we need to say is the unite function. We're going to mention the 2 columns that we want to combine, and then we just say the name of the column. So in this case, it's just going to be new. And so if we run that, it collapses these 2 columns into one, and it's going to say new, it's a character, and it's the 99, or the 19, 99, 2000, 99, etc. Great. Now, something to note here is we have this underscore, and that's because it sort of assumes that when you collapse these 2, you're just going to put an underscore in them because it doesn't really know that it's a year and that we write years without an underscore and things along those lines. So all you need to do is use the set function, and you're just going to say equals and then 2 quotes. And so this is basically saying, well, what do we want to separate these 2 columns by when we combine them into one cell? This is saying, well, we want to separate them with nothing. So there's no space in between them. And so when we run that, very simply, it's country, new, and rate. Great. So unite, very, very easy. Just new name and the things that you want to combine. Awesome. So the last major thing that I want to cover, so those are the 4 main functions, but one of the hardest part about data wrangling is what do you do with missing data, number 1, and number 2, how do you know when there actually is missing data? And so this seems a little counterintuitive at first, but there's actually 2 different ways that data can be missing. There's explicitly missing data, and there's implicitly missing data. So explicit missing data is when it's denoted by a symbol. So as we were mentioning earlier, we might have an NA or an NAN or a hashtag or a period or something along those lines. That's when someone was nice enough to actually say that something was missing. But if you look at this, it looks like this is complete data except for that single AN or NA. But you might ask, like, what else is missing? Well, it turns out if you know a lot about your data, there's 4 quarters in 2015, and there's supposed to be 4 data points here, so 4 quarters in 2016, but it's actually missing. And so this sort of relies on you having a ton of knowledge of your actual data to be able to understand that there is missing data and then figure out what to do with it. So if I just have this stocks, so this is just creating a new table for us, and it's stored in stocks. We might want to do something like this where we make the fact that the data is missing implicit. So we're going to use the stocks, our little pipe function, and then we're going to pivot, use our pivot wider to spread out our data into a new tidy format. So what do I mean by that? Well, when we run this, we're going to, or near tidy format rather, we're going to have quarter, right? Where this previously was denoted here where there's 1, 2, 3, 4, and then there's 2, 3, 4, and the first quarter is missing. We're going to put that into its own new column in the front, and then we're going to actually pivot from the year into these 2 columns here. And so this here is actually a way to use these tools, so pivot wider, into an untidy format so we can actually see where the issues are. So there's 2 missing values here by sort of making this transformation. And so I know that seems a little tricky here. So I just want to say that one more time to make it really apparent. So in our stocks tibble, and I'm going to print this for us just so we can see it after we make this. So we have stocks, year, quarter, return, and here it's showing us that there's only 1 missing value, right? So to detect it, what we're going to do is we're going to use the pivot wider function to move the values from here, which we would traditionally want, and we're going to pull the values from return, so from here, and then we're going to pivot them up into column names, which again is a non-tidy format, but we're doing that to try to catch whether or not there's any missing data. And so when you do these sort of transformations, you might do them knowingly, or you might do them as sort of exploratory analysis, right? And that will tell us sometimes that there is missing data. So that's all we did here. Great. Now, once we're sort of in that format, so we're going to repeat that function here, we might want to drop those explicitly missing data points. And so the way to do that is real simply, you're going to have our stocks, we're going to pivot wider, which is, again, the same thing that we did up here. And then we're going to double that with pivot longer, right? Which is going to move our years back down into our position using the, or back into the sort of the year and the return columns. So years are no longer going to be in the columns, they're going to be turned back into row observations. But then we're going to drop the NAs, so the missing values. And so we see here that we're no longer have any NAs in our value. We've dropped the 2 rows, this one and this one, that had the NAs. So that is one way to deal with missing data. Now, the reason I kept talking about why it's so complicated and somewhat philosophical at the start is, that is a valid way to deal with missing data, but you're also deleting data, right? So, we're only missing 1 value in each of those years, but we're getting rid of all of that data. And so if you have, other sort of points that are attributed to that data point, you're also throwing those out. And so you need to explicitly say that you're throwing out that data and justify why you're doing it. Otherwise, you might want to leave them in and then just sort of exclude it down the line in some other way. So that's just something to keep in mind. Great. So another powerful tool that you can use to deal with data is the complete function. And so it essentially takes a set of columns and it finds all the unique combinations within those columns. And so this is just a way to essentially assure that the original data set contains all of the values and then fills in NAs explicitly where necessary. So it's sort of a way to sort of do this, but just within the complete function. And so again, just to remind you what stocks looks like, we're going to do stocks, hit run. We're going to see it's the year, quarter, return with 1 missing value here, but then we're going to use the complete function, and it's going to be able to find the other one automatically. And so how do we know that? Well, it's going to say, well, what are the things that we want to complete? Well, we're going to use year and quarter, and what we're essentially going to get is it's going to find any missing values in any of the other columns. So instead of having to sort of do this really complicated, pivot wider, pivot longer technique, we can just use the complete function to automatically do that for us, and it's going to find those 2 missing values. And it's going to fill them in with an NA as well. So then we can decide whether we want to drop them, so use something like values drop NA, or just leave them in there and decide what to do later on. Great. Now, the final thing that I want to show you in this workshop, which I actually use a lot, is this fill function. And so when people will write something very repetitively, especially say like written text that you're scanning into a digital format and then importing into R, people will write say a long name, so Derek Whitmore, and then they'll sort of have little ellipses or something that we know intuitively references the entry above until we get a new unique name, but we might not want to write out every time. And so the fill function knows that, and it actually will fill in any missing data below, given or with the name from above. So if we had this table that we're sort of creating, and we are calling it treatment, and then we want to fill it in a particular way, i.e. fill it with the person name, it's going to fill every NA with the value, the most recent value that's specified. So since there's 2 here and the last entry that was specified was Derek Whitmore, it's going to take that value and fill it into each of these NAs until we get to a new person, which in this case is Catherine Burke. And so what does that look like? Well, it's going to do Derek Whitman, and then Burke. And so everything else is the same. And so fill is helpful if that is the format that you're sort of following, but it's not something that you want to use to just deal with NAs just because you have them. So you need to have an informed decision, or you need to be informed for when you use fill. And then make sure you're explicitly saying that that's what you're doing. Great. So again, sorry, this was just a rough, brief introduction to the idea of data wrangling, the key players in the Tidyverse for sort of doing these basic skills, but something that you find out, why is this so difficult? It's really just problem solving and sort of figuring out where your data is coming from, what does it look like, and where do I need it to go? But once you do that, it's more straightforward in terms of how you do that. Now, it turns out that most of the holdup is because things are not so nice, and so because we don't plan at the very, very start with how our data is collected and stored, or we have a bunch of errors in how it's collected and stored, then that sort of causes problems that we need to solve in really unique fashion going forward. So I will have this notebook sort of linked in the YouTube description, so you can download it there and sort of run through this on your own. I'm also going to have this R script that we had earlier, and then I'm also going to have sort of the case study questions. So you will be able to see those, just download them and sort of submit them. You can work on them in groups and things along those lines, but then I'm happy to sort of pass along a certification to show that you were able to successfully complete this workshop. So in a second, I'll sort of just quickly show you what those case studies are. But if you have any questions, please let me know and reach out. Again, really utilize the textbook that I referenced. That's where most of these examples came from, so you can definitely go through that as well. They have explanations in there as well if I didn't present something as clearly as I should have. But I think that this is all of these sort of core features that you need to successfully jump into data wrangling and then kind of run with it on your own. So thanks so much for watching, and I'll hop over in a second to show you the case studies, and then you'll be all set to sort of work through them on your own. Thanks so much. Hi everyone. So to wrap up the workshop, I want to show you the 2 questions that I'm going to ask you to solve. Only one of them, the first one, problem 1, is required for you to sort of write up the code in an R script, save it, and then email it to me. If it's correct, I will give you a certification. The second problem is a very big challenge, and it is not required, but it's an entire different order of magnitude of difficulty than the first problem. So if you find the first one to be very trivial, please challenge yourself and give this a go. But it is not required and is something that's quite advanced. So it's very much a real data set. So the first one is to tidy this classroom.csv, which I'm going to link in the description of this YouTube video. And you can get the answer in 4 lines, and it uses read CSV with multiple arguments, a pipe, the pivot longer function, and then just the standard print, no extra arguments required for that. The actual data set looks like this. So we have a header here, name of the student. We have the assignment type here, so quiz 1, quiz 2, test 1, and then missing, so they didn't complete the assignment, and then a bunch of grades here. So you can go ahead and solve that and submit it, and that will be great. I'm not going to show you what the tidy version of that looks like, because I'm hoping that you're going to piece that together and sort of reason through the principles of the sort of tidy framework. But if you're able to do that, you've successfully completed this workshop. If you really struggle with that, I encourage you to go back and rewatch parts of this or look through the notebook and things along those lines. Great. Now, the problem 2, which again is not required for certification and is way harder, is working with the Who data set, which is in the tidyr package. And so I've printed it here. So again, you can just do print Who. If it's for whatever reason not popping up for you, you just do library tidyr, load that, and then you will be able to print Who. So boom, boom. But your goal is to get this data set in a tidy format. And so there's 2 things I will say. So one, the answer to this is in our textbook. So it's sort of a walkthrough case study. So that's why I'm not requiring it, because it's very easy for someone to look up the answer. But the second thing is, if you do this without looking at the answer and you're sort of unfamiliar with the data set, it requires you to do a lot of critical thinking. So you have to figure out where the redundancies are, what variables mean. You might have to look up some extra functions in terms of splitting, weird data formats and things along those lines. So I really encourage you to do this. I think if you don't look at the answer, but you are relatively comfortable with R, it will probably take roughly 45 minutes to an hour, depending on your expertise. If you're very new to this, it will take probably substantially longer. That doesn't mean you shouldn't, try to engage with it, but I just want you to know this is sort of the an example of a real common, real world data set for you to sort of work through. So just wanted to put that out there. 2 challenges. The first one's required, but the first one you should be able to do, if you're very comfortable in a relatively short period of time. So hopefully it's enough to, test your skills, test your understanding, but not so much that it's like an overbearing task. Great. So thanks so much for watching. I really appreciate it. Reach out with any questions. And other than that, I hope to see you in the next workshop or just see you on Twitter. Thanks so much. Bye-bye.